AAT, this is section 3.1 video. This is part 1. We have part 2 and part 3 coming up as well. And here in this chapter we're going to be talking about polynomials. A polynomial comes from the word poly, which means many, and nomial, which means term or number. So it means many terms. Polynomials have constants. Constants are just nice little numbers, variables, and exponents. Only 1, 2, 3. In other words, no fractional exponents or no negative exponents. Polynomials can be a monomial or a sum of monomials. So here's some examples of some polynomials. This is one single monomial, which are numbers, meaning constants, and variables and exponents. All these are connected by multiplication. It's okay to have this 4 on the bottom here because this is the same thing as 3/4 times x, a coefficient, a number times a variable. But it's not okay to have an x in the denominator or have a negative exponent because that would mean bring that y down to the denominator. So those are not polynomials. So we're going to classify the polynomials in a couple different ways. First, having to do with their terms and having to do with how many terms they actually have, the number of terms. So first, the degree of the polynomial has to do with if it's a polynomial in one variable. So this is a polynomial in an x and a y. But if it's a polynomial in just x, for instance, if its highest degree, meaning its highest exponent is 0 for that x, and we know x to the 0 is just 1, we call it a constant, like number 3. That is a type of polynomial because it's the same thing as 3x to the 0. A linear polynomial would be something where the highest degree on an exponent of x is just 1, so like 2x plus 1, and we know this graphs a line. We've done that before. A quadratic, done lots of those, is where the highest degree is squared, and you may or may not have a x term and a constant. But even if it was just the 4x squared, it'd still be quadratic because your highest degree is 2. Notice that I'm putting these in decreasing order of degree, but they don't have to be. Sometimes they don't start out that way anyways. Cubic, so might just be something like 8x cubed, or it might have an x squared, an x, a constant added to it. Quartic, know that number is to the 4th, like 6x to the 4th. We might skip a cube term and go right to x squared term. May or may not have an x term. May or may not have a constant. Quintic is to the 5th. So like maybe negative 8x to the 5th plus, let's say, x to the 4th plus 6. Highest degree is to the 5th, and nth degree, like if we wanted to say the 16th degree, the highest degree would be 16th. So if it's the nth degree, it would just be anything to that n plus a bunch of lower degrees. Okay, so to classify them by the number of terms, if you have one single term, one monomial, everything's connected by multiplication. This is 3 times x times x times x times x 9 times. It's a monomial. Binomials, we know, are 2 monomials, like this. Trinomial would be 3, regardless of its degree, 3 monomials. And a polynomial on 4 terms, anything after 4, 4, 5, 6, and so forth, we would just call it a polynomial in 5 terms, 4 terms. So, you know, something like this. Like that squared plus an x plus an 8. How about that? So in a polynomial, sometimes you'll see it in function notation. You, of course, have a coefficient in front of a monomial. If you don't see a coefficient, like right here, we know that number in front of x is just 1. The first coefficient we're going to call the leading coefficient. This is the cubic term. The linear term, if it's an x to the first, and the constant term will be your number there, usually at the end. So like this 4 here would be the quartic term. This 3 would be the cubic term. This is our linear term. This to the 7th would be, we don't have a name for the 7th, so we just say that's the term for the 7th degree. So write each polynomial in standard form. So that just means we want to put them in decreasing order of degree, then classify each polynomial by its degree and its number of terms, and finally name the leading coefficient of each polynomial. So the 3 things we have to do. So this standard form, actually 4 things we have to put in standard form, make sure it's in decreasing degree. That is a binomial because there's 2 things. Name it by its number of terms, and it's quadratic because its highest degree is 2. Leading coefficient is the coefficient that comes up front, which is a 1. Leading coefficient is 1. Okay, next one. This looks to me to be cubic. Oops, sorry. Don't be careful of that. We need to start out putting it in standard form. So this is a negative 3x to the 4th needs to come first. Make sure that negative stays in front of that coefficient of 3. Then we got an x of 3 going down, then a 2x squared. Almost got me on that one. So this is to the 4th, so it's called quartic. It has 3 terms, so it's a trinomial. Quartic is to the 4th. And its leading coefficient is that first number once you put it in standard form. Make sure it's in standard form first. That's going to be important for later. So put this one in standard form. My highest degree is that cubed. Then the squared. Then we got a negative 4x and the 2x. Sometimes we got to combine like terms. That's a negative 2x if we put those together. So now that we've simplified it, putting in decreasing order, this is a trinomial because there's 3 terms. It's cubic because its highest degree is 3. And its leading coefficient is also 3 right there. All right, moving on along. Number D, letter D. Okay, 1 single term here. Sometimes that's the hardest kind. This is just a constant, classifying it by its degree. So when its degree is 0, it's x to the 0. That's called a constant term. It is a monomial because there's only one thing there. And its leading coefficient is 5 because this is kind of like 5x to the 0. Okay, do E. Pause the video, do E, and then we'll come back and do F together. Okay, and there's the answer to E. Put it in standard form. There's 3 terms, so it's a trinomial. Its degree is 7th. We don't have a name for the 7th degree, so we just call it 7th degree. And the leading coefficient is negative 6. Okay, to get F in standard form, we have got to FOIL it out, and sometimes we're just going to mass distribute first. So first is x cubed, outer negative 3x, inner is 2x squared, and last is negative 6. Make sure it's in decreasing order of degree. So now, highest degree, so this is cubic, because it's to the 3rd. It's a 1, 2, 3, 4 terms, so you just say polynomial with 4 terms. So once it gets past trinomial, you just say it's a polynomial with how many ever terms. And its leading coefficient is, of course, 1. If you don't see a number up there, then it's just 1. Okay, flip it on over. Fundamental theorem of algebra says that every polynomial with degree greater than 0, so degree greater, if it said equal 0, that would just be a constant. So as long as the degree is greater than 0, it has at least 1 root in the set of complex numbers. Remember, the complex numbers are really all real and imaginary numbers. And we already found roots. We know roots are where y equals 0. So roots are going to be the x-intercepts. There's where y equals 0, and there's 1. This means real root. in this degree 1 equation. This degree 2 equation, this would be quadratic, would be 2 or 0 real roots. 2 or 0. So this has 2 x-intercepts in my picture, but it's possible that that parabola could have been like floating up here. And so the roots that we would have found had been imaginary. Imaginary roots come in pairs, which would mean we'd have 0 real roots. So both of these are possible. In this picture, I have 1, 2, 3 real roots. It's a degree 3, so it's cubic. But we're going to say there's 3 or 1 real root because, now I can tell from this picture that there are 3 real roots, but it's possible that my cubic could have been like 1, 2, 3, something like this, and only had 1 x-intercept, 1 real root. So again, we're going to subtract by 2 till we get down to 1 or 0. Degree 4, there's 1, 2, 3, 4. This is quartic. Degree 4, it has 4 real roots in the picture, 4 x-intercepts, but it's possible it could have had 2 or it could have had 0. So again, we're subtracting by 2 till we get down to 0. Degree 5, quintic. In this picture, we have 1, 2, 3, 4, 5 real roots, so that's the maximum, but it was possible I could have had 3 or had 1. So I kind of want to show you here a picture of some possibilities. So go on to video 2, and then we're going to look online at some different pictures of what can happen when you have all these different degrees. Okay, go on to the next video.